Okay, let's look at this worked example. This is something you guys really, really need to know how to do, and it might be a little bit new. So what we're doing here, a car of mass 1,000 kilograms traveling west at 20 meters per second crashes into the rear of a stationary bus of mass 5,000 kilograms. The vehicles lock together on impact, show calculations to test whether or not the collision is inelastic. So you need to prove mathematically whether or not energy is lost. How can we possibly do that? Final initial what? Velocity? How do you work that out? But that just gives you the energy. That can't tell you if you've gained or lost anything. What have I said? If ever you can do something with it without using energy, do it. Momentum. Use momentum to work this out. All right? And you're going to see why, because the energy is going to mess up our calculations. So, let's work out our momentum. So our momentum initial is going to be the momentum of the car plus the momentum of the bus. The momentum of the car, how do we work it out? Mass times velocity. 1,000, our velocity is 20. What's the momentum of the bus? 0. The bus isn't moving. So our initial momentum is 20,000 kilograms per meter squared. Hang on, kilograms, yeah. Oh, meters per second, sorry. 20,000 kilogram meters per second. That's our initial momentum. What's our final momentum going to be? Sorry? What's the value of our final momentum?
20,000.
20,000. So our final momentum is going to be also 20,000. Right? Now, we can work out what the speed of the objects after our collision are from our momentum equation. So our final momentum, now remember these things have locked together. What's their mass?
6,000.
6,000. So their mass is 6,000. We don't know their velocity. So rearranging, their velocity is going to be 20,000, which is their final momentum, divided by 6,000. So what's that? 3.33. Okay. So we have the final momentum of our vehicles involved in our collision. Now, we need to work out if this is elastic or not. So we need to work out the kinetic energy before and the kinetic energy after. So, our kinetic energy initial.
Sir,
Yes.
isn't it 20 divided by 6?
Yep.
How is it? Oh, wait, no, I didn't say anything.
All right. I'm still recording, so I won't threaten you this time.
Yay.
Okay. So our kinetic energy is 1/2 mv squared. Now, our kinetic energy of the bus is what? Before the collision, the bus, 0. We don't have to count that. Our kinetic energy of the car, 1/2 times mv squared. So 1/2 times the mass of the car is 1,000. Our velocity is 20 squared. So that will be 200 times, well, 200,000. I think. Yep. So our initial kinetic energy is 200,000 joules. Let's have a look at our final kinetic energy. Oops. Kinetic energy final, again, is 1/2 mv squared. What's our mass now? 6,000. What's our velocity? Good. All right, I need someone to work that out for me. It's about 10, 60, 30,000, something like that. All right, let's call it 32,000, roughly. 33,000. All right. 33,000 joules. So we had a kinetic energy starting of 200,000, a final kinetic energy of 33,000. We have lost a lot of energy due to heat and sound. Okay, a lot of energy due to friction. So we know this is an inelastic collision. And this is why, when you're given a problem in an exam and you can use momentum, never ever use energy. Always use momentum. Look how different these two values are. If they asked you for the final speed of the objects after they collided, look how different you're going to get. Make sure you use momentum if you can. Only use energy if you must. Yeah.
You have to write the end like a bit forward.
Yes, you would. Yep, so at the end, if you got this question on an exam, you would have to say, initial kinetic energy was this, final was this, there has been energy lost, therefore this is an inelastic collision. I can't stress this enough. Always use momentum if you can. All right, energy is going to mess you up.